What up, dudes? Sorry I can't be here with you today. We're checking out the second half of solving systems by elimination. This is advanced elimination. It's the same idea, just with a little trick ahead of time. Some of you are probably comfortable with it already. Some of you maybe need to see it in slowed down motion. So anyway, at the top of your notes, you can put 4.3b, it's part 2, solving systems using advanced elimination. Do try this warm-up. It's not elimination, but it will keep you fresh. Yes, you can wait for me to do it, but you should pause me and try to do it on your own. That's how you remember how to do things. So here's the idea. There's an equation of a line. We want to write the equation of a line that passes through this point and goes perpendicular to this line. Perpendicular. Get it? They're kittens. Adorable. So this line 3x plus 4 looks like this. 1, 2, 3, 4 is there, rises 3 and runs 1. So this is the line that we want to be perpendicular to. So we want something that looks like that, right? But we want it to go through 2, 5. 1, 2, 1, 2, 3, 4, 5, somewhere like that. So this line should go through there. So we can try to figure out where this is and find the slope, but we can do this algebraically as well, because this line has a slope of 3, which is 3 over 1. Sorry, I'm writing with my finger. So the slope of this is 3 over 1. We want a perpendicular slope, so we want an opposite reciprocal of that. So the perpendicular to this is negative 1 over 3. Great, so we want that slope, but we want this point. So I want this to look like y equals mx plus c, but I want to use that 0.25. I don't really know what the c value is. The c value is like where this perpendicular line intersects the y-axis, and I don't really know where that is, but I know that this x value and this y value work for this equation. So in place of this x, I can put a 2. And I should get a 5 out when I have that equation. And we're going to put in the slope that we know we need, negative 1/3. Right? All right, so excuse me when I clean that up. So I know that when I put a 2 into the equation, even if I don't know c, I know what I should get out. It's 5. Let's solve for c. This is negative 2/3, so add 2/3 to both sides. And you should be left with c. So we could figure out, let's see, we have to add fractions. 5 is 15/3, and 2/3 is 2/3. We can add those, so that should be 17/3, right? So c is 17/3. And now we can plug it back into the y equals mx plus c equation to give you the whole equation. So you get y equals the slope that we know we need, m, and third x plus our intercept that we found, 17/3. Cool. I hope you guys remember how to do that, or if not, can follow along and be like, yeah, I remember that, because I enjoy things I remember. Speaking of that, so I want to give you a little recap about solving systems just by elimination when the math gods are kind to you. This is what we looked at last time. Hopefully you were there. And this is nice because I know that we can add and subtract equations and get also valid other equations. And what's interesting about these is these both have the same coefficient. I guess one's positive, one's negative. If we add these, we can add all the x's together. You say x plus 5x gives you 6x. It's a terrible 6. And negative 2y plus 2y gives you 0 y's. Yes, you can just write nothing, but it helps me to keep things straight if I write a little more. This is negative 19 plus 1 gives you negative 18, and that's really nice because you have 6x equals negative 18. and you can divide by divide by x, divide by 6, and you get -3. Cool. We're 90% done, but only have half of the answer. We take our 3 and put it back into either that x or that x. Pick the top one because it's easy. You get -3 minus 2y equals -19. And when you solved, we got 8. Right? Fine. Cool. That's what we did last time. I hope you're okay with it. The only problem with that is that sometimes the math gods are not kind to you, and this one's at 1, this one's a 5, this one's a 3, and this one's a 2. You can only really play this game if these two have the same coefficients. So that's what we're messing with today. That's the advanced part of it. There's no big difference aside from sometimes we have to modify the coefficients. So this might be pretty obvious, but equations can be not only added and subtracted, but multiplied. So this is true. 5 plus 3 is 8. And if you multiply both sides by the same number, you get also a true statement. Right? So you get 10 and 6, and that's equal to 16. That's true, right? So we're not changing anything by multiplying both sides of the equation by the same thing. We're going to use that to our advantage here. So check this one out. Hope you can see what I do here. This is a problem because these are not the same values and these are not the same values, the coefficients, the thing in front of the variable. But I do see that this one, if I took this and doubled it, I could get 10y, excuse me. So I'm going to leave this one as it is. In fact, I'll take a little screenshot and put it down low. I'm gonna modify my system. So I'm gonna take this system here, this simultaneous equations, and modify it. And I'm gonna modify it by multiplying this one on both sides by 2. And I'm gonna multiply by 2 because I want the 5 to become a 10, and then I can eliminate the 10s. Right, so this will distribute in, ba-boom, and you get 4x, and you get a positive 10y, and on the other side you get -2. Cool, nice. Now we have this. Those are both 10s. One's positive, one's negative. The actual sign doesn't matter too much. It just changes do we add them or subtract them. I want to add these together so they eliminate. So then we'll add these as well. So -8 plus 4x gives you -4x. -10y plus 10y gives you 0y. And 14 plus -2 gives you -12. And so you should get x is 3. Cool. You plug that back into any one of these equations, whichever is easiest. Either we know I think x is 3. That's my guess. Let's check. Yeah. Oh. Positive 12. Why don't you guys say something? So that's -3, and then we can take that x value and put it back into any one of the x locations. We can put it back into here, or we can put it back into here, or we could put it back into this modified one. You simplify and solve for y, and there's your y. Cool. What I'd like you try, see what you did there. What I'd like you to do is try this one. Think about, it looks similar, but think about how you would modify, which ones you would modify to solve this. Cool, pause me and try that. Ooh, answer's 3, 3. Okay, so we're going to do the same thing. These look easiest to go after because I can multiply the top equation by 5. So I'm going to do that. I'm going to multiply both sides, don't forget it, by 2, not 5, sorry. drop that in to both of here, distribute, so you get 4x. Let me just type it out, that might be easiest. You get 4x minus 5y, minus 10y equals negative 18. And in the denominator, you have this same thing. So, sorry, I'm drawing with my finger, which is slow, annoyingly slow. So this one ends up, let's color it purple. We modify the top by multiplying everything by 2, right? Multiply this by 2, we get this equation. These are the same system. One has just been modified a little bit. And what's nice about this one is the coefficients on one set of variables are the same value. They're opposite signs, so I can add them together. We'd say 4 plus negative 8x's gives you negative 4x's. Negative 10y plus 10y gives you 0y's. Should write it down, but I'm slow. And negative 18 plus 6 gives you negative 12. So x should be 3. Right? That one we did before, so this should be here. X is 3. We plug 3. We know x is 3, so you can put 3 in here, or here, or here, and solve for the other variable. Should be 3 as well, make sure you can get that. Your solution you leave as a point in space, 3, 3. Neat? Alright, last issue is sometimes like I can't multiply 4 by anything to get 7, and I can't multiply 3 by anything to get 5. So sometimes we have to multiply both equations to make the two variables have the same coefficient. Usually one thing will be easier to attack. I think here the 3 and the 5, I want to get the y's to be the same, just because I think both of these, I'm going to turn both of these into 15s. It's just a smaller number than turning both of these into 28s. I think this is easier to do. So I'm going to multiply this whole equation by 5 and this whole equation by 3. And it'll look like this, right? I'm going to packet this one up, packet that one up. I'm going to multiply this all by 5. Multiply by 5, multiply by 5, multiply by 5. That'll be our top equation. Let's call that, so multiply by 5, you get negative 20x plus 15y equals 40. Cool, and then in the second one you get negative 21 plus 15, yeah, good, 15y, and that, x, and that gives, and then 36. Cool, so that's the bottom equation. Right, they're the same thing. This top equation is just this multiplied by 5, and this one is this multiplied by 3. And what's nice about that is we haven't changed the essence of the equations, but I do have the coefficients on the y that are the same. Since they have the same sign, I should subtract them. So you go, so you go 15 minus 15 gives you 0y, that's fine. 40 minus 36 gives you 4, that's fine. This one's a little fussy, and sometimes I have to write this out if you want to see it nicely. You go negative 20x, do take time to write these out, right? Negative 20x minus negative 21x. You're subtracting a negative, which means you're adding. So you get negative 20x plus 21x. So you're 20 meters underwater and you go 21 meters up, means you're 1 meter above water. So this is x, just 1x. So 1x equals 4. So there's our x is 4. Now plug 4 back in anywhere that it's easy. So plug it in there, or there, or there, or there, and you should be able to find that y is 8. Cool? Try those. Here's one more if you want to see it again. I'll try one more for you. We're going to go quick through it because we're running out of time, and hopefully it goes all right. So this is ugly because I can't turn 3 into 4 or 5 into 6 with one multiplication. So maybe I'll take the 3 and the 4 and try to I'll try to multiply this whole thing by 4, this equation by 4, and I'll try to multiply this equation by 3. Like that. Okay. When we do that, we multiply everything by 4, you get 12x minus 20y equals negative 12. And the second one, when you distribute this in here, you get negative 12x plus 18y equals 3 times 4 gives you 12. Okay, that's not too bad. So I just got 12x from here. 4 times negative 5 give you negative 20. 4 times negative 3 give you negative 12. 3 times 4 give you the negative 12. The 18, the 12. Cool. What's nice about that is that these two have the same coefficients. They're opposite signs, so let's add them. 12 plus negative 12x gives you no x's. Negative 20y's plus 18y's gives us negative 2y's. And negative 12 plus 12 gives you 0. You divide both sides by 2, and y is 0. That's fine. Okay, so y is 0. Y equals 0, and then you plug your y back into either this y, or that y, or that y, or that y, and solve for x, and you get x is negative 1. Cool? I hope that makes sense. You're doing number 4, 5, and 6 from that same page as before. It starts on that front page and then keeps going to the next pages 5 and 6. Cool? Try that. Good to see you.